Is the recording now? Okay, good. Um, uh, Vector is an advanced number. You can look at it as an advanced number. And I will start in 1 hour. Matrix is another advanced number. And the reason mathematicians created this, of course, there's a reason. And you will see in 1 hour. Okay? The vector, again, has a direction. Uh, last time I said, and if you, even though you are not president of some country, if you see a country, 50% people wants heading this way, and another 50% people wants to go this way. 50% people. Let's say both are equal. Then you can tell if the country is in chaos, 50 no government, 50% people want to go this way, 50% people want to go that way. Then you can tell what the country going to, which direction the country is going to. Which direction? Diagonal of parallelogram. Okay, I just enjoy it, it's faster. Okay, so the country will head in this way. Okay, the country will head in this way. What's so funny? Okay, and so, like I said, if 80% people wants to do this, if 80% people wants to do this, and 20% people wants to do that, 20% people wants to do that, so what is the country going, which direction the country is going to head in? By taking, don't think that the country will go this way, okay? 80% people, yeah, we will close to this way, to this direction. But because 20% people are pulling on that way, and so the parallelogram, this is a vector, okay? Vector A plus vector B. So to draw the parallelogram, because I have drawn this a million times, so I just by hand. Okay. So the country will go this way. Oops. The country will go this way. So this has some impact on the country, but the strongest impact from this group people. These are group people. If you are the president, you better to follow by the nature's law, and you say, I'm leading the country go this way. And everybody says, oh yeah, you are the greatest president. And you say, oh, I love the algebra class. choosing a different, if you are following the majority, and the 20% people will be mad at you. If you are doing this way, and everybody feel you have listened to their own opinion, even though they are not quite satisfied, but they feel you have listened to their own opinion. Somehow you have adopted their own opinion in the national policy. Like Abraham Lincoln, the greatest president in United States. And so the vector does give us a lot of good things. Please open your book to the page 50. Please open your book to the page 50. I'm not going to go through this. You read this application. The fourth vector. Fourth vector. Vectors is a force. I'm sorry, force is a vector. For example, if here is there's a slope, there's a slope, okay, and let's say a car. Let's imagine this is a car, okay, stopping on the slope. Let's say this car has 10 kilograms. That's too light, but 10. The weight is 10 kilograms. Okay. So this is the Earth. The Earth attract the car on the slope. The car is standing still on the slope. Let's say you know the angle. Of course, you can measure the slope angle. It's a 30 degree. It's a 30 degrees. This is a 10 kilograms. Or a box, whatever. Or a stone. Because it's standing still. So naturally, you can think there's an opposite, it is exactly opposite force acting on it. Otherwise it will moving, right? The net force is 0. So you can imagine an invisible one is 10 kilograms. Straight up. To cancel the weight and become 0. So the total net is 0. So where the 10 kilograms come from? Where this force come from? Where? One way is the friction, right? If no friction, this will move. if it's no friction at all, uh, we're sliding out, right? This is a standing still. Standing still. So let's say this is a 10 kilograms, okay? So everybody knows there's a vertical, straight down, okay? But because it doesn't move, so you say is the net effect is zero. The net effect is zero. And 1/4 is the friction, parallel to the slope. No cell phone, okay? Parallel to the slope. The direction is going up. Okay? And another force, if there's only one force on that direction, then we cannot get this. Then this force plus this force will sum, right? This one plus this one, where is the force? Parallelogram, okay? Parallelogram. So the result will be this. The result will be this. The reason this doesn't move, because the surface has a force. Vertical, this one is parallel, this one is vertical. Okay? One is parallel, one is vertical. Okay? And this is 90 degree. This is a 90-degree angle. These are vertical to this one, parallel to this one. This is a 90 degree. Okay? One is the friction. The friction is pushing up. Friction is pushing up. And this one is pushing vertical. This one. The two, this one plus this one produce this one. Okay? And this one cancels this one. This is why it's a steel. The reason here can steal, these cannot steal, because the friction that is not enough. Anyway, so how much is the friction? How much is the friction? How much is this force? So it has to be joint aligned to the. So this is the friction. This is the friction, and you draw it. And this much is the force against the slope. This adds up. So I take here friction and I don't know how to say this term. you know what it is from the surface, from the holding, pushing, okay? So this one plus this one ends up to be this one. No chatting, okay, guys? No chatting. Ends up to be this one. Okay, we can say, how to label it? Friction. Friction. F, force. And friction. Okay. A vector. This is a vector. And I say force holding. This is another vector. The two force ends up to be this. To be this. And this, if the basically is you can say three vectors ends up to be zero. Three vectors ends up to be zero. Because this plus this add this is this. Okay? And this one add this one. They are opposite direction and the same length. So it's zero. So the net force on this one is zero. It's zero. And on page 50, they're talking about hanging a TV, hanging a TV. Page 50, the application. Example 1.35, talking about pulling the, how to say, truck, or what's called, what is it called, the wagon, a wagon. On the next page, example 1.36, they are talking about hanging a TV. Is a hanging on what? A painting. You hang a painting on the wall by two slopes, and they are not symmetric. They are not symmetric. Different angle. Different angle. Okay. So the hanging. I just briefly. So let's say the hanging rock or whatever by two slopes. One slope, let's say this is the ceiling. This is the ceiling. One slope is this direction. Another slope, for the two nails, for some reason they do not hang it symmetric. Normally when you hang something, you put it in the symmetric. But for this, and this rock has a weight, of course. Has a weight, of course. And this rock is steel, stainless steel. So you can tell this force plus this force plus this force is what? Is what? Is the opposite of this one. Okay? Is the opposite of this one. This one plus this one is the opposite of this one. Okay? And so you know this one, how much is the weight, you know this one. And you can calculate how much is this, how much is this. For this one, it's easier because because the slope, this direction and this direction is vertical, is slope. You read it, okay? If you need me to go through this, you can ask me. And I think these are very interesting. Um, and for hanging on page 58, question 8, question 8. There's no friction. Do it now, okay? Do this question now. Do this question now. On your notebook. They're asking how much force you need to push. Basically, it's a friction, okay? How much to push? So this one doesn't slide down. There's a little bit of geometry trick involved. Of course, trigonometry. There's a little bit of high school geometry involved. You need to know what's this angle. You need to know what's this angle. You need to know what's this angle. They tell you this is a 30 degree. So what's this angle? And the red one, what's this angle? There's one is a 30 degree, one is a 60 degree. Blue and red, can you tell which one is a 30 degree, which one is a 60 degree? Maybe by drawing you already realize. This one is a 30 degree, 30. And which one is? This one is a 30 degree, okay? So what's this one? What's this one? 60. And all this goes straight, okay? This one totally straight. This one is a parallel, this one. So this one and this one are the same. And since you are telling me this is a 60 degree, because 30 degree, 60 degree. So this one is a 60 degree. This one is a 60 degree. So this one is a 30 degree. 30 degree. How large is this? How large is this? How large is this? 10, 10, okay? 10, they are canceling each other. So the question is asking, how large is this one? How large is this one? This is a turn. This is a 30 degree. How large is this one? How large? $30. 30 degree. How much is this? Is half. Okay, this is a few magic angles. The relationship is half. If this is a 30, if this is a 30 degree, the one facing it, this one facing, is half of hypotenuse. The one is half of hypotenuse. Okay. So this one is half of this one. This one is a 10, and so it is a, how much is that? 5. How much is that? It's a 5. Yeah. It's a 5. So we need 5 kilograms. I say friction, or the book says because no friction is the one to somebody use a finger to push it. They want to use no friction. They want to calculate how much the finger is giving out the force. Okay. Assuming there is no friction, what force parallel to the ramp must be applied to keep the block? Are you following? Yes. Are you following? Yes. Write it down on your notebook. Write it down on your notebook. When you review that, you maybe. And do 11. After 8, do 11. And 12. The chart scared me, so I skipped the question number 9. The chart. Actually, we can do the chart. Do you want to do question 9? The chart, a tow truck is towing a car. Question 9. After 8, do question 9, do question 11, and do question 12. Because you guys are mechanical engineering, and so these are the force. Somebody stop the recording.